1.3, transformations of linear and absolute value functions. Let's jump into it. These are kind of written kind of small, but I'll write what you need bigger so you can get it on your paper. So horizontal translations versus vertical translations. Today we're going to get actual formulas to write equations of our transformations. We've talked about what transformations look like, correct?
Yeah.
Now we're going to get the formulas for writing the equations of the transformations. Okay? So, for horizontal translations, the graph of y equals f of x minus h is a horizontal translation of the graph of y equals f of x, where h does not equal 0. So for under horizontal translations, you need to have this formula written down. Y equals f of x minus h. You need to have that written down. You need to have that written down under horizontal translations. Subtracting h from the inputs before evaluating the function shifts the graph left when h is less than 0 and right when h is greater than 0. So I kind of talked about this the other day a little bit. This is inside our grouping symbols, correct? So we do the opposite of what the sign tells us to do. Okay? So you need to have the formula written down. Y equals f of x minus h. And once again, the horizontal translation just shifts my graph left or right. It doesn't affect the size, the orientation, or the shape of the graph. Just picks the graph up and moves it left or right. Okay? That's my horizontal translation. Everyone have y equals f of x minus h written down. Okay. Okay, vertical translations. Write down vertical translations and then write down this formula. Y equals f of x plus k. Write that down for vertical translations. The graph of y equals f of x plus k is a vertical translation of the graph of y equals f of x, where k does not equal 0. Adding k to the outputs shifts the graph down when k is less than 0 and up when k is greater than 0.
So what was the other one? Was it a horizontal translation?
Yes. So horizontal translation is y equals f of x minus h. Vertical translation is y equals f of x plus k.
Why do we add a whole new... Never mind.
Like I said, this is vertical. So vertical translation just shifts my graph up or down. Once again, it doesn't change the shape, the orientation, or the size of the graph. Just picks it up, moves it up or down. Are we okay with horizontal and vertical translations?
Here.
Okay, am I able to move on? Example 1. Writing translations of functions. It says let f of x equal 2x plus 1. Write a function g whose graph is a translation 3 units down of the graph of f. So we're on letter A right now. Write a function g whose graph is a translation 3 units down of the graph of f. So if I'm moving my graph down, is that going to be a horizontal or a vertical translation?
Vertical.
Vertical, because it's going down. Vertical is going to be up or down. Horizontal is going to be left or right. Does that make sense? So since I'm moving it down, it's going to be a vertical translation. So which formula am I using from the previous slide?
Y equals f of x plus k.
F of x plus k. Okay? Everyone understand why I'm using y equals f of x plus k? Because that's for my vertical translations, and I'm dealing with a vertical translation right now. Okay? So, I've got this formula, and I've got to figure out what to plug into this formula. I'm just adding k to my function. So what is my function in this case that I'm given? What's the function that I'm given up top? F of x. What does f of x equal? 2x plus 1, right? So where it says f of x, I'm going to replace that with 2x plus 1. And it wants a function what? Function... Can we see that? Function g. So my function is going to be g of x equals, I replace f of x with 2x plus 1. And then my k value is how many units I am translating it. So which direction am I translating and how many units? 3, and I'm going down 3, right? So you think it's going to be a plus 3 or a minus 3?
Minus 3.
Minus 3. So I plug in minus 3 for k. Does everyone see that? My f of x equals 2x plus 1 replaced this f of x. My translation, 3 units down, replaced my k value. So I got 2x plus 1 minus 3. Does everyone see that? And now, I can just combine my like terms. What's 1 minus 3? Negative 2. There would be my answer for letter A. This is my function g, whose graph is a translation 3 units down of the graph of f. Does everyone see how we got that? And how we use that little formula? We okay with that?
It's a little interesting. Can we do another one?
Yeah, we're going to do letter B. Can I erase and move to letter B
Of course.
if we don't have any questions? Letter B, we still have f of x equals 2x plus 1. Letter B says write a function h whose graph is a translation 2 units to the left of the graph of f. So what kind of a translation is this?
To the left, you say?
It's to the left, yep.
Horizontal.
Horizontal, because it's moving left or right, correct?
Yeah.
So it's a horizontal translation 2 units to the left. So which formula am I using from the previous slide?
F of x minus h.
Very good. Y equals f of x minus h. Now, on letter A, I just took a number and added it to my function, correct? It was my function plus k. Do you think that's the case here? Do I have my function plus or minus a number? No, I'm doing f of x minus h. Right? What do you think my h value is here?
Your horizontal number.
It's my horizontal translation number, which is,
Plus or minus negative 2, right?
it's negative 2. Why is it negative?
Because you're going left.
Because I'm going to the left 2. So I'm replacing my h with negative 2. Right? So that turns into f of x plus 2. Right? Now let's think back to Algebra 1 real quick. Let's say I was given the function f of x equals 2x plus 1, and I wanted you to find f of 5. How would you find f of 5 if you were given that function? What did I replace x with here? 5. So I'm going to replace the x with 5 in my function. Do you guys somewhat remember that from Algebra 1? It's function notation. So you replace the x with 5. You got to do that within your function. And I get 10 plus 1, which is 11. I found the value of f of x when my x value was 5. Kind of the same concept here. What did I replace x with in my f of x? What? Huh? Not just 2.
Pick up.
X plus 2. Right? Took the x out of the parentheses, and I put x plus 2 in its place. Right? Does everyone see that? I know it can be a little confusing, but instead of f of x, it's f of x plus 2, right? So I took the x out, replaced it with x plus 2. So I'm finding f of x plus 2, but I'm going to call it h of x because it wants a function h. So in my function, when I see an x, I'm replacing it with x plus 2. Same concept as when I found f of 5. I replaced the x with 5. Right? This time I'm replacing it with x plus 2 because that's where it wants me to evaluate the function, is x plus 2. Does that help make a little bit more sense or no? Is there any confusion that I need to clear up? What can I do here with that 2 being multiplied by the set of parentheses? Distribute. 2 times x. 2x, 2 times 2. 4. What's 4 plus 1? 5. There would be my answer for letter B. I know it can be kind of confusing, but does everyone see that I have f of x plus 2? So I replace my x with x plus 2. Just plugging that value in for x plus 2. And then I evaluate. Okay? Are there any questions on letter B? Any confusion I need to clear up?
If you were moving it right, would you plug in -2?
I would plug in 2 to h. So it would be f of x minus 2 that I'd be finding.
Okay.
Does that make sense? Okay.
Where'd you get the plus 1?
That's from my original function. Because remember, I'm just replacing the x with x plus 2. So it becomes 2 times x plus 2 plus 1. Any other questions? Those are good questions. We okay? Okay. Moving on. Reflections. Once again, I'll write these a little bigger for us. So we can reflect our graphs about the x-axis, and we can reflect them about the y-axis. So put reflection in the x-axis. Write that on your paper. Reflection in the x-axis. And then next to it or underneath it or something, so you know that it corresponds to it, write the formula y equals negative f of x. Y equals negative f of x. If I multiply my function by a negative or a -1, that reflects it over the x-axis. Okay? Does everyone see that the negative is happening to my whole function? Negative f of x. Multiplying the outputs by -1 changes their signs. So I'm changing the signs of all my outputs. So if I have like 2, 3 here, that turns into 2, -3, because I changed the sign of the output. Okay? It's reflecting over my x-axis. Does everyone see that? Everyone have reflection in the x-axis and y equals negative f of x next to each other. So I'm multiplying the whole function by a negative or a -1. Okay? Now write reflections in the y-axis on your paper. And then next to it, or beside it or something, write y equals f of negative x. Y equals f of negative x. So what would I be plugging in for my x value here?
-1.
Negative x. Okay? The graph of y equals f of negative x is a reflection in the y-axis of the graph of y equals f of x. Multiplying the inputs by negative 1 changes their signs. So I'm reflecting over the y-axis now. Okay? Does everyone have this formula written down next to reflections in the y-axis? Does everyone notice that for some of our transformations, stuff is happening to our whole function? And then for other transformations, stuff is happening inside the function. Right? Can I move on to some examples of reflections? Let's do it. Okay, so let f of x equal the absolute value of x plus 3 plus 1. There's my function that I'm given. F of x equals the absolute value of x plus 3 plus 1. Letter A. Write a function g whose graph is a reflection in the x-axis of the graph of f. Write a function g whose graph is a reflection in the x-axis of the graph of f. So which axis am I reflecting over?
X.
The x-axis. So which formula am I using?
Negative x. Well, y equals negative
Y equals negative f of x. Right? Because it tells me it wants it reflected over the x-axis. So I'm just multiplying my function by what?
negative 1.
Negative 1, right? Because it's negative f of x. What does it want me to name my function?
G.
G. So I'm going to call it g of x. What is my function?
Absolute value of x plus 3 plus 1.
Absolute value of x plus 3 plus 1. So I'm going to take my whole function and multiply it by that negative 1. Does everyone see that? Because it says negative f of x. F of x is this junk right here, right? So I'm essentially plugging that in for f of x. So I get negative f of x. It's like negative 1 times f of x. So negative 1 times my function. Say what?
Is that a one?
Where?
Negative, is that negative one?
Right here?
Or your parentheses?
Yep.
Oh.
Because this is like a negative 1 f of x.
Well,
Negative 1.
I just couldn't tell because it was close to those parentheses.
Okay, I got you. So now I can distribute that negative 1 inside my parentheses. I cannot distribute a negative 1 inside of an absolute value, but I can multiply negative 1 times the absolute value. So this will just turn into g of x equals negative absolute value of x plus 3 minus 1. And there'd be my answer. Because I can't do any more simplifying there, can I? Are there any questions how I got that? Yes.
So so basically, once you take the stuff out of the absolute value, turn it to negative because you can't multiply absolute value by negative, right?
Say it again.
Okay, so like, if we take the absolute value sign away, right?
We can't do that because we don't know what x is.
Okay, but like, if we did, it would make it a negative because the negative's on the outside
Yep.
of the absolute value.
So let's say I just had the absolute value of 3 there. What's the absolute value of 3?
3.
3. So I'd multiply it by that negative, which would make it negative 3.
Okay.
But, like I said, we can't do that because we don't know what x is. Okay? Other questions on letter A? Can I erase and do letter B? Erase in letter A. Letter B. Write a function h whose graph is a reflection in the y-axis of the graph of f. Which axis am I reflecting over now?
Y.
Reflecting over the y-axis, so what formula am I using?
The y equals f of negative x.
Very good. Y equals f of negative x. Everyone okay with that? identifying which formula to use at least. Okay. Now I'm plugging something in for x, right? Because it's telling me to find f of negative x. So what am I replacing my x with?
Negative
Not negative 1.
1. X plus 3.
What did I replace x with in this f of x?
Oh, H.
No. Circling it.
Negative.
Negative x, right? Usually that's f of x, but now it's f of negative x. So in my function, and I'm going to call this function h because it wants a function h, I'm replacing my x with negative x. Just like that. Took the x out, replaced it with negative x. Can I do any more simplifying there? No, I can't. There's my answer. Does everyone understand that? To reflect over the y-axis, I just replace my x with negative x. Okay? Questions about writing reflections of functions? We okay there? Can I move on? You guys look so thrilled to be here.
Don't worry, Coach Mac. I am.
Good, I'm glad.
I don't look like you?
Okay, horizontal stretches and shrinks versus vertical stretches and shrinks. This is where it gets fun. Okay? So write horizontal stretches and shrinks on your paper. And then write down this formula. The graph of y equals f of ax is a horizontal stretch or shrink by a factor of 1 over a of the graph of y equals f of x, where a is greater than 0 and a does not equal 1. Multiplying the inputs by a before evaluating the function stretches the graph horizontally, or away from the y-axis, when 0 is less than a is less than 1, and shrinks the graph horizontally toward the y-axis when a is greater than 1. So you need to have that written down. Y equals f of ax by a factor of 1 over a. Does everyone have that written down? Okay, write down vertical stretches and shrinks. And here's my formula. Y equals a times f of x is a vertical stretch or shrink by a factor of a. Of the graph of y equals f of x, where a is greater than 0 and a does not equal 1. Multiplying the outputs by a stretches the graph vertically away from the x-axis when a is greater than 1, and shrinks the graph vertically toward the x-axis when 0 is less than a is less than 1. Does everyone have these formulas written down before we jump to an example?
Which one's which?
Does that help?
Top one's stretches.
Top one is horizontal stretches and shrink. Bottom one is vertical stretches and shrinks.
I'm gonna be honest.
Does everyone have these formulas written down?
Yeah.
Hurry up and get them written down. You need to have all these formulas on your notes. That'll tremendously help you whenever you're doing your assignment. So that way you can know which formula to use. Okay?
Say
Say it again. Let me know when you got that written down. You got it? Okay. Here's our last example for today. Says let f of x equal the absolute value of x minus 3 minus 5. Let me write it bigger. Let f of x equal the absolute value of x minus 3 minus 5. So the first part, letter A, says write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So let's do this first part first. Write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. All right. What kind of a stretch or shrink is this?
It's horizontal shrink.
Horizontal shrink. Does this help? Does that help?
Yeah.
Okay. It's a horizontal shrink. So for letter A, which formula am I using?
Y equals AX.
Y equals f of AX by a factor of what? By a factor of 1/A.
So would it be 1/3?
So, my A value is 1/A. So what is the factor up in the problem it gives us? 1/3. So if I do 1/1/3, if I type that in my calculator, someone type in 1 divided by 1/3, what does that give me? 3. So I'm plugging 3 in for A. Did everyone see that? For our horizontal stretches and shrinks, we've got to do a factor of 1/A. So I take my factor, put it under 1, type it in my calculator, that's what I'm plugging in for A. Okay? Can I erase this little sidebar about our factor?
Yeah.
Okay. So, what am I replacing with x in my function?
1/3. Well, 1/3. I mean 3x.
If I'm finding f of 3x, what am I replacing x with? 3x. I got to use the whole thing that's in the parentheses here. Just like I used x plus 2 earlier, I got to use 3x here to replace my x with. And what is our function going to be called? G. So we'll say g of x equals absolute value. Take the x out, replace it with 3x. Can I simplify that any further? No. So here's my answer for letter A. Does that make sense? Questions there? Okay with letter A? Can I erase and move to letter B? Erasing and moving to letter B. Okay, write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So what kind of stretch or shrink is this?
It's a vertical stretch.
Vertical stretch. So which formula am I using?
Y equals
Very good. Y equals a times f of x by a factor of what?
A.
Factor of a. So what's my a value here? What's my factor in the problem it tells me?
2.
By a factor of 2. So do I have to put 1 over a? No. So what am I plugging in for a here?
2.
So I'm doing y equals 2 times my function. Does that make sense? For vertical stretches and shrink, you don't have to do 1 over a, you just do a. So what is 2 times f of x telling me to do?
Multiply. Double it.
Double what?
Your x.
Not x.
Your f.
My f of x.
Yeah.
What is my f of x?
X minus 3 minus 5.
What'd you say?
He said it.
What'd you say?
Absolute value of x minus 3 minus 5.
Very good. What are we calling our new function?
H of x.
H of x. So h of x equals 2 times my f of x, which is absolute value of x minus 3 minus 5. Does everyone see that?
Yeah.
What do I do with that 2? Distribute it. Can I distribute through the absolute value? No. So that's just going to turn into 2 times the absolute value of x minus 3. And then what's 2 times negative 5? Negative 10. Can I simplify that any further? There's my answer for letter B. Questions on that? Are we okay? Did we kind of get the gist of it a little bit as we went through it? Or no? Okay, maybe our assignment can help us.
We have 3 minutes. Okay.
Here's our assignment. We'll make this due on next Monday, which is the 13th. On Canvas. Okay? Are there any questions about my notes before I end the recording?